Hello and welcome to Lux Debugger Programming stream every Tuesday night. Except for last night. We didn't do last night because Black Lives Matter, and I wanted to give some attention over to that cause. We're back tonight, although Black Lives still do matter. And today we're going to be doing something. Let's bring it up here. This is the problem statement right here. Only allow placing a breakpoint where there is a corresponding line of code. The code view should only show hovering lines of code that allow breakpoints, which is data that we can pull from the DIA SDK, and only allow the user to create breakpoints on those lines. When a code file is reloaded, if a breakpoint exists that has no corresponding line of code, it is moved to the next valid line of code within 3 lines. If that doesn't exist, then the breakpoint is automatically deleted. This is within an order of magnitude functionality that Visual Studio has. Currently, if you try to, in Lux, set a breakpoint and that line of code is not debuggable, then you just get an assert. And we really want to clean up all these asserts and get rid of any bad behavior that the user can possibly run into while running Lux. And this is part of my mission to do that, right? Like, Lux is starting to mature to the point where, you know, I can use it in my day-to-day activities, and so this is what I want to do. So that is our plan for today. I have absolutely no idea. Well, I have some idea. I have some idea about like what I can do to get this data and to display it and all this stuff, but I haven't really done much research. If you watch the stream, you know that a lot of times I struggle. So we're going to watch me struggle live on stream. It's going to be great. It's a lot of fun. I generally am able to make progress on the thing, and today I'm optimistic about this one. And it's exciting because it's an area of the code that I haven't really dug into too much before. So if you want to try out Lux Debugger, which you can see is in alpha state, I'll load it up real quick. It's in an alpha state. We have a free alpha program that you can join if you want to try it and give feedback. This is the debugger right here. Okay, there is an entirely new paradigm for how you debug programs available as part of Lux Debugger. Completely new interface. This is in an alpha state, so everything looks very basic. Of course, that will be improved by the time the software is in full release. So, so this is give you a quick tour. This is the process tree. People who have seen my stream before should be familiar with this, and all of the threads are available. This program is not very. This is one of my test programs, so it's not very complicated. But you can see all the threads available here. Right now, I just display their thread numbers, and then inside each thread you have a stack, and the entire thing is a tree. It makes it very easy to traverse the program. It's all in one place. There's no such thing as a current stack. So this is the type of thing that I'm doing with Lux. It has an entirely new user interface. Never before seen a debugger. I'm very excited about it. Again, you can go to luxdebugger.com to join the alpha. There's a link in the description of this video. And today is also a very exciting day for me because I put a new version of Lux out today with a bunch of cool features. Mainly focused on helping Lux be usable in by myself in order to debug Lux. So it's very new software. It's rough software, and we didn't have things like line wrapping. Okay, so you can see these lines that get very large floating point number. They now get wrapped properly. This is a regular size floating point number. This is a very large floating point number. So a lot of things like that I've been doing recently, and you know, before this would just scroll off the screen. You couldn't see the whole thing. So okay, quick tour over. Go to luxdebugger.com if you want to join the alpha, and let's just get into it. So, where do I start here? Probably in this file. Close all the work I've done before. Okay, at some point I have to display all of the lines of code that are available in a file. We should also bring up the DISDK documentation. Pull it up right here. This documentation can be rough, but I've figured out how to navigate it in order to get the data that I need. Generally, you know what I have to open? One of these two, source file, compilant. Okay, there's a lexical hierarchy of symbol types and a class hierarchy of symbol types. And these are, I think, mostly orthogonal. I think what I want to do, again, I haven't researched this ahead of time, so I could be way wrong. But I think what I want to do is load up a compilant, which is a C++ name for a source file that has been compiled, and query out of it its all of the lines of source code. I thought there would be, so like a compilant is a DI symbol. There should be a way to get, so like if I just go to, DIA symbol, here it is. There are a lot of methods here that I can call. I think not only the ones that I was just looking at in there are viable. I think all of these are actually viable. And one of these is going to be find, wait, A, B, C, D, F, G? F comes before G. Find symbols, find children. Oh, that's the first one. One of these is find children. I think you can use find children with like a line of code, symbol locations. I think find children should be available for like every symbol. And I think maybe what I can do is find children on the compilant and then get like a compilant details, compilant environment. Just there should be something in here that I can use to. Not any of this stuff. This is like class hierarchy. This is like types. This is like the type system. This is what I need somewhere in here. Let's see whether there's any similar code already existing in my symbol query class. My symbol query class is what. Hey, oh, it's Dave Chat again. What's up? Definitely a repeat customer, Dave Chat. How you doing, man? So somewhere inside symbol query, I'm pretty sure I get source lines. So let's see if I can source location. Yeah, so you get source location of main procedure. I've discovered that if you query the global symbol, if you do global symbol find children, I think there might be different behavior, like a different semantic behavior, than if you call a particular symbol find symbol. I think in some cases it's recursive and in other cases it's not recursive. So that'll be a gotcha that we should look out for. Here's a nice find lines by address function in the session object. Okay, that's maybe a thing that we can take a look at. By the way, I think I didn't mention this in the stream. I love answering questions or explaining any parts of the debugger that we're looking at here. Please feel free to ask me anything and randomize me. I'm happy to talk about anything. Okay, so I think this is what I mean. I think that if you call DIA session find children, it's recursive, and otherwise it's not. Like the DIA symbol find children is not recursive. I'm not exactly sure, and it doesn't say anything about it in the documentation. Right? Oh wait, I searched the wrong thing. Recursive. Yeah, it doesn't say it. The word recursive is not present. Retrieves all children of a specified parent identifier. Retrieves the children of the symbol. I mean, that kind of implies that this is not recursive and this is. So maybe what I want to do is I actually want to use the session and not the symbol. And I can do like find lines. Retrieves line numbers within the oh, look, I can pass it a complement. So what's going on? We've missed the first part. Today I'm going to do, when you, actually, I should give a demonstration here real quick. Where's Visual Studio? We're getting close to the debugger being usable, just on its own. But we still have some problems, like if I set a breakpoint in a line of code that doesn't have any corresponding code, right? This is just an empty line, and I run it, and it's gonna be like, bonk, assertion failed, that addresses, can't find address for source location. So this is what we're trying to fix. And the design that I would like, and it dies, or it doesn't die, but it gives me a stack trace. The design that I would like is, so what happens in Visual Studio, that I want to improve on is, if I can do it. I can put a line of, if I'm not running the app, then I can just put a line of code. I can put a breakpoint anywhere. Breakpoint anywhere I want to. But then when I press F5, it goes boop. See, it like moved it. It moved it without telling me, mind you, that it moved it to a line of a valid line of code. And so what I want to do, and yes, the white UI really hurts. Oh wait, do you mean that it's bright, or do you mean that this interface is, I mean, I'm aware that this interface is kind of janky because it's new software and I haven't hired a UI artist to make it look good yet. So what I want to do is I want to put a little symbol here in the gutter of the source area to represent everywhere that I'm allowed to place a breakpoint, right? So if I F11 to step into this, oh, thank you. Then this is going to be the first breakpointable line of code, and then they will all continue. But this one won't have the little symbol, and this one will, and I think probably the last line of the program will have it, and then nothing after, like this line just won't have it. Right? And it won't let me put it there because it won't have it. So that's what I want. It will mark all of these lines of code as having, this is an interesting, the assert failed, but I can still interact with the UI because the assert failed in the debug thread. So the debug thread is locked right now because it's asserted, but the UI is still responsive. This is like the benefit of my design, is that I can still, even if I have an assert window up. Anyway. Okay. So we were looking at the documentation. I think all I have to do, this thing literally right here, this function, I was worried about speed, but now I'm not so worried anymore. Retrieves line numbers within the specified complement and source file identifiers. Okay. The fact that, generally I've found with the ISDK is that, if I call a function over and over in order to like iterate, and there are 16,000 of them or something like that, if I call find symbol by address with 16,000 different addresses, that will be very slow. If I am able to call once and there are 16,000 results, then DISDK generally returns very quickly. And so I am actually heartened. I'm encouraged by the fact that there are find lines here, and it takes a complement, and I can just, so this is great. This is great. Okay. So we're off to a good start. I'm thinking that all I have to do is get the complement, pass it in here, and get the result and stuff it in an array and return it back to the UI. So this is exactly, I got lucky and somebody at Microsoft already did this for me. Okay, so I'm gonna take this and return it back to the code text area, which has to then display it here in some kind of, yeah, this is the code that I use to render all of the text. And I think what's gonna happen, somewhere here I draw breakpoints. This is where I draw print points. This is where I draw checkpoints. But that's not where I draw regular breakpoints. Execution lines? What is that? Oh, this is where I draw the little yellow ticky mark that represents where the current line of execution is. Here it is. In the gutter, breakpoint, loop breakpoints. This should be like, this color should be, I'll get color for breakpoint type. So it just depends on what color. This is where I draw breakpoints right here. So then somewhere around here, I have to draw valid lines of code. Okay, I can do that. Let's see here. I think what I want to do it, like, here's what I don't want to happen. The debug thread is going to do this work to query the DI-SDK. It's in a separate thread. I put all the DI-SDK stuff in a separate thread so that I can, so I don't have to worry about the UI blocking and becoming unresponsive if any debug operation takes a long time. So I'm just gonna have to plumb this data through from the UI to the debug thread and back. And I'm gonna need to set up some kind of like cache, right? Because I think that, ooh, what's going on here? I think that, I have to think about this. I could have many source files open, and this is a problem. And if I'm tabbing back and forth between files, right? Let's open it up. Okay. What I don't want to happen is that, you see, now I'm on types.cpp. Let me find a different. Here's another source file. Hello? Oh, nope, it didn't like that one. Okay, here's initializer list, which is one of the C++ standard library source files. So every time I tab back and forth, there are two ways of doing this. The naive way is that I click this tab, and then it makes a call over to the debug thread. This is an asynchronous call. And then it does the request. It finds the data, sends it back, and in the meantime, I don't get my little red ticky marks. Okay. Actually, I'm gonna have that. I'm gonna have that no matter what. Like, the ticky marks are not gonna show up for a moment, no matter what. At least the first time you load the file. My decision that I have to make now is, do I throw out that data every time I go to a new tab, or do I hold it? Well, where do I store that data? Do I store that data? Do I just throw it out? Do I have some kind of cache somewhere that keeps all of this debuggable lines of code data in like a cache so that I can grab it later? Do I store it in code text area? Actually, storing it in code text area might make the most sense. So I have a few different questions. One is, where do I store it? Two is, when it gets updated because the program got recompiled, I have to get it again. I have to re-get it. And so I have to know, so I have to have some kind of like flag here. Actually, now that I think about it, I don't have this at all, and I need it for other stuff too. So like I have this get source location of main procedure. That can get to be out of date. I think I just realized a bug that I have. Let's check this out. So Lux is running, and we have the source location of the main procedure. What I'm gonna do is I'm gonna move. Oh no, that won't work. That won't work. I need to like move this somewhere else. I need to move my main procedure somewhere else and then see whether it's still valid after I move it. But I'm realizing that I think I only call this once at the very beginning of, yeah. Get source location of main procedure. Oh, that's not useful. Debug thread, debugger screen. On set executable. Okay. An on-set executable is only called once when you... Okay, so there's actually no bug here because I naively did the right thing. Yeah, on-set executable is called whenever you... Basically whenever you press one of these load buttons. Okay, and then it takes you to the main. But if I go back, it unloads everything, so it's forced to call it again. So I actually don't have a caching problem there. I think I also don't have a caching problem with... Oh, no, I do. So this one will fail. Get all source files. If I add a source file to a program, while Lux is open, it won't recognize the new source file. Okay, so I, in fact, already have this bug, and I just didn't realize it. So I should definitely code up a solution for both of them. So data that I get out of the DISDK can become obsolete if the PDB information, if the debug library is reloaded, which it is reloaded every time. I think every time you run. I don't quite remember when I reload, but I think every time you run, yeah, every time you press F5, it's reloaded. So, so that means I need to have some kind of cache that gets invalidated when you reload the DISDK. And then anytime the user wants something, they access it through that cache. And hopefully nobody stores any of the data that's in that cache. So what I actually need here, it's not going to be stored in code text area. I need a new bus. I need a new bus that is the interface to a cache that that reloads every time, that manages all of this data. And the result of get all source files will actually go into that cache. So I'll need to change that. So let's see, get all source files. Oh, literally the other line. So on set executable, yeah. Source files future. Promise filled, all source files. Open file searcher. So this needs to be stored not here, but in that cache. So basically I need to create a new object that does all of this. I may as well load the main location in there as well. And then this accesses it through that cache instead of what it's doing right now. I should definitely put that in the engine. So let's do it. Let's start coding. Pragma, good old Pragma once. Man, life was not as good before we had Pragma once. I remember that. I remember those days. I'm old. Namespace engine. But soon Pragma once is going to be obsolete. Soon, because we're going to have modules. Yeah, modules. Modules will be good in like a decade when we're all actually using modules. Let's see, namespace engine. I have to name it something. Okay, first let's make the bus. We're just gonna copy another bus. We do want a singleton bus. Okay. And what's gonna be the name of this thing? Symbol data cache. Symbol data cache. Oh wait. Symbol data. Oops. Data cache. .h. I have taken to stuffing the bus and the object that backs the bus in the same file. It's fine. There's something to be said about, like, you should separate those things out, but I don't think that actually gives you any value, because so like here, symbol data cache, and then down here we're gonna have a class symbol data cache. Okay, ideally you would put these in different files. The problem is, without an actual pointer or reference to a symbol data cache, you can't access anything in it. The only symbol data cache that will exist, I'm probably actually going to put it here, main.cpp, symbol data cache. Like, you know, I'll just put it in my main. I do this sort of thing a lot, where I just create an object in the main function, and then it lives on the stack for the entirety of my application, and there's no way to get to it other than through the bus, and so I don't actually worry about putting this in a different file, and then everything is nice and in the same file. Easier to read that way, you know. So we're going to include symbol data cache. And debug engine, I should probably create it after the debug engine, but I guess I can make it before I create in the UI stuff. Yeah, that's fine. Symbol data cache, symbol data cache. There, I made it. I made this thing. And let's public symbol data cache bus handler. It is a handler of the symbol data cache bus. It will be the one and only unique handler of a singleton event bus that will have two functions in it to start with. I will say, do not. Oh wait, let's say what is it? What is it? This interface is an accessor for all data retrieved from the debug symbol library. In other words, a PDB on Windows backed by the DIA SDK. Don't store any of this data. Don't persist it anyway. Persist any of this data. The difference, I would say, between store and persist being you can store things in a local variable, but that's not persisting them. Persist means, like, don't make them the member of any class where it stays even after a stack frame is done. Don't persist any of this data. This this interface handles updating the data if it changes. In other words, the user recompiles and a new symbol library is available. Okay, cool. thinking about this interface, we actually want the, there are two possible things that could happen. One is that you call it and it's in the cache and it returns the information. Two is that you call it and it's not in the cache yet. And it has to return some kind of flag that says, hey, try again later. So here's the C++, like here's like the academic way of doing this is you return an optional. And if there's an object stored in the optional, then you're good. If there's not, then it's cached, and that's like try again later. The less academically correct and maybe, but maybe like less objectionable to some people who dislike stud optional is get all source files valid. You call this, and or I guess you could just do like this. Actually, I think this is my favorite. I think I've decided what I'm going to do here. Yeah, it'll be just like this. Result. Yeah, I think this is actually our interface right here. Which means that you are required to check this bool value. Now I'm wondering, do I enforce that you have to, do I enforce that you have to check? Do I have like no discard on anything? I know that I use no discard. So no discard. For anyone who may not know, no, I think I have to manually put this here. Yeah, there you go. No discard. No discard means if the value returned from this function is not stored, then that is a compile error. Super useful for us. Oh, and look, I did do the right thing. Singleton event bus automatically puts no discard on invoke result. So anytime someone calls into my bus, they must use the result. Okay, good. Then I'm actually, so the danger here is someone calls get all source files, and it's not present in the cache, and it returns false, but they don't check, and then they still try to use the result like it's valid. But that's not gonna happen because, okay, so I think we're good here. Let's also do it for the other one. Result. And then we're gonna add a new one, where this is a pure virtual. This is also a pure virtual. And this will be a, no, file system path for the name of the source file that we're looking up, and it will return a stud vector of, I have to make a decision here. Do I do a stud vector of source location, or do I do a stud vector of integer because all I need is the raw integers? I think I'm just gonna do it, and this is what I'm using to represent, excuse me, integers. Source location. Where did I define that? I thought I defined it in a file called source location. It's in debug data, isn't it? So there it is. Okay, int64t. Yeah. Just in case I have more than 4 billion lines in a file of source code, I want to use the 64-bit integer, just in case. Can't put 32 here. Okay. Get debuggable source lines. Cool. Let's fill these out. Okay, I'm also going to have to make a new file called symbol data cache.cpp, include symbol data cache.h, namespace engine. We'll just copy paste this stuff. Symbol data cache. Boom. Return false. Done. All right. Since I added some source files, we're gonna have to rerun CMake real quick. And there we go. Okay. So we have the bare bones of this setup. Cracking my neck there. I'm gonna go ahead and wait, where is it? I'm gonna go ahead and replace the existing instances of, yes, save that, of get all source files and get source location of main procedure with a call to this function. No. I have to find it here. Yes. Get all source files. I'm going to need to do this instead. No. This is not where it goes. Get all. Here, right here. Oh, interesting. Interesting. Where I call it isn't actually where I need to use it. Okay, so what I'll do is, so if you press Control P, you want all of those files to show up immediately. So this on action is like the user just press Control P, and I don't want to sit there and wait for all source files to be returned. Is a wait the first time a problem? No, we can definitely, okay, here's what we'll do. So all source files. We'll definitely call it here. Okay. We'll replace this call because this is onset executable. So we'll call it once here, onset executable. Bool get all source files result equals. Okay. So we're going to call it right here with a fake result. This will fail. All source files. All source files. This will fail because this will, like, the data isn't there yet. So this will be false, but that's okay, because then by the time the user goes to press Control P or click that search files button, the data will have arrived, because this call requests the data. It will go through and, right, it will trigger the DI-SDK to go find that data and store it in the cache. Okay. So let's put a comment here. Trigger a cache of this data right there. We also want the debugger screen to no longer Yeah, like this stuff never belonged in here in the first place. It actually, I'm going to move it to where it does belong now, because we have a cache for it. I was using the debugger screen to store this data, where the futures, these futures right here. I don't need to do that anymore. Yeah, I think I don't need this. I don't need debug updates bus, I think is what I don't need anymore. I don't need, where was it? Promise fulfilled. What bus is that in? Promise fulfilled. That's in debug engine bus. Okay, well, I'm not taking debug engine bus out of here. But I can make this a handler for debug engine bus. Okay. And this is the only one that I need. So, override. Oh, I forgot to put overrides on these. Override. So debug engine bus will tell me when the data has arrived via these futures. I'll just stick this right here in an invalid location just so I don't forget about it later. Improve my posture. Oh yeah, much better. Gotta have good posture when you're coding. Especially when I'm on stream and I like forget what I'm doing. I'm so focused and not goofing up on the code that I forget to have good posture. Pressure's on, man. You're on stream. Okay. So we triggered a cache of that, and then we'll do the same thing for source location of main procedure. This is a source location. I think I actually don't need source location of main procedure in here. Do I? No, I think I actually want to keep source location of main procedure here in debugger screen, because I want to do something with it immediately once it's show source location. Yeah, the question is, if I move this into the cache, then I have nowhere to put this line of code. Okay, I convinced myself. I will return your main location to you. It's fine. You get to keep it. Okay. Yeah. So this one will stay. Cool. But you're going over here. Promise fulfilled. Oh, I definitely need a constructor. We'll do that next. And then here is the cache. You just put that in there. Okay. So now we need a constructor for this. And the only reason we need it is so that we can subscribe to these futures. No, sorry, not subscribe to the futures, but subscribe to the debug engine bus. You have to listen on this bus. Here we go. Debug updates bus. Yeah, this is what we want. Debug updates bus listener. So I'm not sure whether I have described how buses work on stream, but I know that I've not done it on today's stream, so we're going to go through it real quick. A bus is a way to abstract a caller and a listener of an interface. The caller doesn't know who the listener is, and the listener doesn't know who the caller is. So instead of saying include, here's our example. Include the symbol data cache, and there's an object, and you have to have a pointer to that object. And you have to know, like all of the underlying. Okay. Instead, all you need to know is the interface. Like here's my debug engine bus events. They form a bus. You actually never have a pointer to the thing that you're calling into. And conversely, the debug engine object that implements this interface has no idea who called it. So this lets you have a clean separation of different concerns of your code. It's especially useful because I can have two kinds of buses. A singleton event bus, which is something that is like the cache is the perfect example of this. The singleton bus, there's only one object that implements the bus. You call into the singleton bus, there's only one thing on the other side ever. On the other hand, there's a broadcast event bus, which is you call into the bus and it fans out to any of multiple, zero or many, any number, any non-negative number of objects on the other side of that bus that could be listening. So with the singleton event bus, you call either invoke or invoke result. Okay. Invoke is like, hey, do a thing, change some state. Invoke result could also change the state, but then returns a value. The broadcast bus does not have invoke result, right? Because there could be many things. It just has a broadcast. Because there could be many things on the other side of that bus, and it doesn't make sense for many things to return. So this has been a really useful way to structure, hey, there are all these different objects in different places, and there might be many dependencies in between them, and I can manage the dependencies if I make buses like this. I really like the idea of buses. I've been using them a lot while writing this debugger. So symbol data cache is the object that implements the bus. And so you just have to have a little bus listener. Just like this. Symbol data cache bus listener. And there. Now I've registered this symbol data cache object as the object that listens on the symbol data cache bus. The one and only object, because this is a singleton event bus. Cool. Now, I can delete this one. These functions here in the bus will get forwarded to this class. So this is how that works. Okay, so cool. That worked out great. So we are going to... Oh, there's still one thing left. We have to do all source files. We have to replace this instance with another call to all source files. So actually, I have a bug here, which is that if let me see, Let me see whether I actually get this bug. No, ignore. I love how sometimes I read code and I realize, oh my god, I have a bug. If I press this and then I press Control P really quick, faster than it takes for it to load all the source files, nothing will, or it will be an error. See, that wasn't fast enough. But I think I do have a bug there, in that it won't, it won't show these source files fast. If it hasn't loaded the source files fast enough, then this will be an error. Oh, hey, look at that. Look at that. There's no main.cpp. There's no process panel. Yeah, so that is a bug. If I close this, escape. Hello, escape. Oh, do I have to just pick a file? Okay, yeah, if I close it or reopen it and now main.cpp, there it is, yeah. So I do have a bug. Okay, and that bug is specifically that I actually never checked to make sure that this has anything in it that's valid before I go using it. So what is the behavior that I want to happen in that case? I guess my options are don't show the panel, but show what information I currently have. Show the panel, show what information I currently have, but have a indicator that the data is still loading and will, yeah, I think this is the answer that I want. Yeah, so if you press Control P and the data is not loaded yet, then it should just show like a little ... I'm loading. And then when the data becomes available, refresh it, show all the data there, show all the source files. That is what we actually want to happen. Okay. And I do have a file. Let's look at File Searcher. Basically this, I have to call this again. Set search file list. Can I, oh man, there's like all these edge cases here. If I set search file list while the list is open, then will it freak out? Like what will it do? Search file list right here. Max results, and file picked. Wait a minute. Search box. So this is only if the text changes. Wait, but somewhere I have like, oh right, because I currently don't support the up and down arrows, so it's not even a problem. Like if I support pressing up and down to move within this search box, which I don't currently do, right? Pressing up and down does nothing. Then I have a problem where if you add or remove things from the list, then that indicator might go out of date. But right now I only support clicking something, so I'm not even gonna worry about that. I really should implement that at some point, but not gonna worry about it right now. So yeah, I really just have to recall set file search list if I get new data. And call this with like empty until then. Yeah. That's what I'll do. Okay, so get all source files result. If Let's do it this way. If I have valid data, show it. Otherwise, show stud vector stud file system, no, file system path empty. Is passing an empty vector the same as is it? I don't think you're ever going to have a project where you don't have any source files. Wait, you are. What if there's no PDB? Yeah. Okay, so what I actually have to do is file searcher. I actually have to have like an overload of this. Oh, this is kind of gross. I have to be able to signal, hey, I don't have any source files, but that's because there has to be a difference between I don't have any source files because no source files exist versus I don't have any source files because we haven't gotten them back from the symbol library yet. So I need to, what do I added like a Boolean here? Show, let's just do this. Show, gross. I don't want to have like a show waiting for source files. Like, what is that? Is that really going to be my API? I guess I could. There's like an obvious solution here that I'm missing. Oh, I know what I do. I just have set waiting for source files. So this will turn some kind of internal flag on. Set waiting for source files. I'll come back to this, and I'm getting kind of sidetracked with the file searcher. I know now that I'm gonna have a linker error because I haven't implemented this yet. So what all this will do is listen, is like show a ... in the UI, listen for an event that the thing has come in, and then refresh itself. So we can do that later. Here's what I actually want to do. Code text area. Well, actually, let's compile and get rid of any compile errors that I've written so far. Of which there are many. Include vector. That one was easy. File system. Oh my god, I can't spell file system. What else is it going to complain about? Memory and future. All right. Are you done complaining? Debug updates bus. Should that be? Oh. Debug engine bus.h is where the debug updates bus. Good. All source files, undeclared identifier. Right. I need to remove all source files. This needs to not be here anymore, and instead should be here. You know, it's kind of telling that I have the main location future here, but I never actually store it. Okay. My symbol data cache. Get all source files. Get all source files. Debug engine bus. Oh, what am I doing? Called the wrong bus. Symbol data cache bus is what I actually wanted. And I probably have to include that. Symbol data cache. And that's definitely going to be in the engine namespace. Is that the next thing it's going to complain about? No. Oh. Wait, why didn't it complain about not being in the engine namespace? Oh, that's why. Okay. Probably shouldn't have done that, but... Cool. Moving on. Oh, it still doesn't like that. Oh, it's complaining about a different spot. Yeah. Same idea, though. Get all source files should be... Good. Symbol data cache bus, get all source files. I think that worked. Debugger screen takes a long time to compile, doesn't it? This is a pretty crappy laptop though, so I'm not that surprised. Okay, good. So now we have an unresolved external. I'll implement that later. I'll be forced to implement it before we're done here, of course, so I'm not going to forget it. So much to keep up in your head, you know, that if you can use the compiler to remind you of stuff like that you haven't implemented yet, so that you don't forget and check in something that's only partially implemented. That's my method of doing that. Okay, so now we're actually going to do the same thing. Let's include the symbol data cache. Symbol data cache. We'll go to paint. I am realizing I actually don't want a vector here. I want an unordered set, which should actually just be called set because sets are not ordered. Wait, do I have to do unordered set? Yeah. Yeah, it's just a set of, if I do vector, then I have to like look in the vector every time for every line that I'm drawing. I don't want to do that. So what I'm going to do right here is draw all the, so I can just assume now that I have it. If I don't have it, then I'll just draw nothing. The cache will automatically get it for me. I will invalidate the screen when it comes in and be forced to paint again. Yeah, that should be fine. Okay. So let's just do the naive implementation first. I'm going to, wait a minute. Breakpoint, draw box. This is what I want. Gonna draw a red box. Here we go. Debuggable source lines. Unordered set of int 64t. Okay. For int 64t line number, and no, that's not what I want to do. Maybe I do need a vector after all, because here I'm gonna loop the unordered set. That doesn't make sense. It may as well be a vector. I wanted it as an unordered set because I was thinking maybe I would draw it while I was drawing the line. But I'm actually not doing that. Yeah, so let's change it back to a vector. So I can walk it in order. Where is my... Okay, that goes back to a vector. Whoops. Okay, it'll be a vector. Vector. I may change my mind again later. I reserve the right. Okay, debuggable source lines. I have to get the gutter area for this line. Oh, I already have that. Line number. Shrink it down by like a lot. So it's like a little dot. Yeah. That's it. I think I did it, folks. That's not even half of it, of course. But I think that's the entire drawing part right there. I think I just did the whole drawing part. Let's see here. Stud vector. Too few arguments for debuggable. Oh, I have to pass it a source line, a source file name. I can do that. What is my source file name? mfile, original path. I think that's what I need. There's a difference between mfile and original path. I forget the details. Let's look it up. Code text area. Original path. Oh, I don't have it documented here. Probably should. I forget why I needed the difference. Oh, I remember why I needed the difference between original path is like what you pull out of the debug information. Let's see, code text area. Code text area. Right, there was something about the difference between where the file is on your hard drive and where the original file was compiled, and therefore is stored in the debug library. There's like some difference between the two. I don't remember exactly what it was though, so I'm not going to write documentation here that could be wrong. But it was something like, I think this is like the original compilation path of the file that you have to use to look up the file if you want to do additional processing on it. So I think that's what we want to pass in here, because this is what the right, like this is what the debug symbol library is gonna expect. The original compiled path, not the path that as it exists on your system, which might be different if you're debugging somebody else's code. Okay. Oh, that's right. We're back to unresolved symbols, of which we only have one. Okay, good. So, what's going to happen? We come to code text area paint. It calls this get debuggable source lines. It passes the original path and the result. And then we're going to go to the symbol data cache. Here we are in the symbol data cache. Get debuggable source lines. Where do I actually call? I'm realizing I never actually put like a message on the on the it has to be there somewhere. I have to put a message. I have to send a message to the engine, to the debug engine. Like I have to call this at some point. Get all source files. Here. No, where do I call it? Oh, I'm silly. I changed my, okay. So I just have to like, I have to do the same thing I'm doing here, except now it is debug engine bus, invoke result, stud future. I'm gonna go ahead and do a diff here to see what that source file said before. Yeah, okay, I just deleted it. Okay, so I just need to take this and put it here. No, in fact, I will just do this. I will just copy it. Copy. Paste. So, yeah. So, but there is a question here. And that question is if I already have a cached result, then I should use that cached result. So I'm going to store a stud optional of all source files. That way I can say if all source files dot, I forget the API for stud optional has value, has underscore value. Oh no, I can just do like this. Okay. Then return all source files dot value, right? Dot value returns a reference. Good. I always have to look it up. Otherwise, if source files future, now I have to do the same thing for unique pointer. If, is there like a, do I have to call dot get? I think I do have to call dot get. Oh, there's an operator bool. Good. If there's a future, return false. Oh no, I'm silly. Return true. All source files equals all source files dot value. No, result equals all source files dot value. So copy it on over. If I already have a future open, return false. Otherwise, make a future. In other words, actually invoke a request to get all source files and return false. Later, promise fulfilled will be called because we're listening on that debug updates bus. And promise fulfilled is called if the debug engine fulfills any promise. So we have to check to make sure it's our promise. So if we have a future and the future status is ready, get the value of the future, dump it into ml source files, null out the future so that another request can be made. There's one remaining thing to do here, which is invalidate the UI. Or no, actually right here, I have to write some code. Code goes here to reload the file searcher. And we're not going to forget to do that because I have my clever unresolved external right here. Okay, so that code, the code that I will need to write here and here are the same code. For now, I will move on to a similar function that is actually what we need. Okay. So same idea. I need another unique pointer to a future, but this one is going to be a stud vector of int 64t, and this will be this needs to be like a map. This actually needs to be an unordered map, yeah. So we don't need the stud optional anymore, but we do need unordered map of a stud vector of int 64t. And then every time we get a new set of debuggable source lines, we have to map a file system path. Every time we get a new one, we just add it to this map. So we just have to do a lookup in the map to see whether we have the one that we need. So if, and let's see, debuggable lines, and this has to be like a vector. Oh my God, a vector of pointers of futures to vectors. Things are getting a little bit crazy here. I think that's correct. A vector, because we might have a bunch of outstanding futures. Of unique pointer. I guess we don't need the unique pointer part anymore if we're putting them in a vector. A vector of future of vectors. A little bit less crazy. Okay. Yeah, I think this is fine. Debuggable lines futures. Oops. Okay. And then here, instead of just an if, we'll do a loop. So if debuggable source lines dot find source file, you know what I'll do? Just give it its own line here. This is like one of the only times that I'm willing to use auto. Right? This type would have been so difficult. It would have been stud, unordered map, file system path to vector, : iterator. I just use auto there. I'm normally like very against auto, but this and in template metaprogramming are the only situations where I'll actually use auto. So if iterator equals, if it's not in my map, sorry, if it is in my map, then result equals iterator, arrow. No, iterator dot second? Iterator dot second. I always forget the syntax. Is it arrow or dot? Is it dot sec? Is it arrow sec? I don't know. Whatever. The compiler would tell me if I get it wrong. I'll just pick the other one. Okay. So we're good. Now, you know what? This has to be another unordered map so that I can look it up here. Debuggable lines futures. So now I have to look it up in the futures list. I should take a step back here and explain what's going on. If I click through my tabs really quickly and open up a bunch of tabs, then it's going to open multiple requests to get all the debuggable source lines. And I need to be able to handle those multiple requests all going off at the same time. So I need to have a list of all of the requests. A future is like a request that will in the future have a value. And then, so there's like a list of requests and a list of results. I get results back every time I do a request. So if I have result iterator, if I have a result, then I return the result. Request iterator. If I have a request, then I just return. I'm good. If I don't have a result or a request, then I have to make a request. What is this called? Source file equals make equal. I don't have to make unique anymore though, do I? No, I could just make the future. Cool. And then I'll have to add something to this bus. So vector of int 64t. And this will be called get debuggable source lines. And I have to pass it a const stud file system path source file. And oh yeah, same thing here. This will only be valid after you call set executable. Oh, I already have that comment right there because I copy pasted. Great. Cool. So this will be get debuggable source lines, and then I will have to pass in source file. Assign that into my list of futures. Wait, debuggable lines futures. Now, whenever I see a promise fulfilled, I have to loop through those futures. Okay. So I have an unordered map of futures. How do you loop through it? God, C++ containers are so hairy. Can I delete from an unordered map while I'm looping? Delete from unordered map during range 4. Yeah, I was wondering whether I just have to do this. Erasing elements. Yeah, okay, I could do that too. Yeah, fine. 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 I'll just use dot erase. Okay. I have to do this in 2 steps. because C++ containers are weird. Auto, what is the syntax here? Auto, iterator, debuggable, okay, debuggable lines futures. Cool, so I do iterator dot, if iterator dot second arrow, wait for all this junk. So if the future status is ready, then m underscore debuggable source lines iterator dot first. So we're just going to assign it into our list of results. Equals iterator dot second arrow get. And then please tell me that stud unordered map has like a erase with a lambda sort of thing going on. CPP reference, the erase. Is it like an erase if, or am I gonna have to erase? Can I have to give it iterators? Erase key. I have to like erase particular keys. Please tell me that I can erase if. Good. Erase if stud unordered map. Erase if. Is this a member of unordered map? No, it's not. Okay, so I have to do stud erase if m debuggable source lines const stud all of this future bool returns a bool, right? You return a bool, right? You return a size? Erases all element that satisfy the... Oh, the predicate. The predicate returns a bool. The example returns a bool, so fine. Return future. All this wait for stuff. So it's technically calling all this wait for stuff twice. I don't care. I think it's basically free. Okay. So great. Clear everything that has been... A result has been returned out of the list. Oh no. This is actually bad. This is actually bad because what if a result comes in... Because this is asynchronous. This is asynchronous right here. So a result could come in between these two. No, this is bad. I don't want to call wait for twice. So here's what I'm actually going to do. Stud vector of stud file system path keys, delete keys, and we add to delete keys dot push back iterator dot first, and while delete keys dot size m debuggable source debuggable lines futures dot erase delete keys dot back delete keys dot pop back. Did I get erase right? Erase. Erase removes the element at that key. Yeah, should work. Should work. So for every, we do wait for once. If it has expired, we put in the delete keys list. We delete everything. We erase everything. I guess I'll call it erase keys. Erase keys. If I'm being consistent with C++ here. My bracelet. Okay, cool. Cool. Same code goes here that went before, honestly, right? Like, still have to invalidate. So some similar code goes here as went there. Okay. Okay. So now I invented a debug engine bus. Get debuggable source lines function that doesn't actually exist in the real debug engine file. So we have to add it. Debug engine. I'm like separating the DIA SDK stuff from the other stuff in this file. Debuggable source lines. Get debuggable source lines. This is just the plumbing part of the job. Get all source files. This is going to be mostly the same as before. We return a future of vector of N64. It's called get debuggable source lines. It takes a file system path. Oh, const file system path source file. Okay. Whoops. Get debuggable source lines. Get debuggable source line. No debug thread is running. Promise. Make promise. Oh, I have to. Add message. And then I have to put the promise and the source file here inside. And of course, this message doesn't exist yet. So let's go make that exist. Debug message. Get here we go. Get debuggable source lines. Returns a vector of N64. Promise. Has a parameter file system path source file. Source file. Cool. Let's go to debug thread. Where this message will be received? Get all source files is going to be. We'll just throw that in the same spot. Debug source lines. Debug source lines. Anycast. Okay, we got the promise. Promise set value. Get debuggable source lines. Get all. Get debuggable source lines. .m source file. Set value. Promise fulfilled. This is where that promise fulfilled is invoked. And yeah, notice it calls the same promise fulfilled no matter what promise has been fulfilled. All three of these promises get fulfilled the same way. It calls promise fulfilled, and then it's up to the. And we can optimize that later if we want by putting a parameter in here that specializes on the thing that is being fulfilled, but it hasn't really been a problem so far, so I'm not worrying about it. Get debuggable source lines.m source file. Cool. So now we're just plumbing stuff through. Debug engine, debug thread. So now we go to symbol query. Hey, we're back to symbol query. Get debuggable source lines, which returns a stud vector of int 64t and takes an argument of file system path source file. So back to symbol query. get source locations for direct. Okay, here's where we actually get to start writing some DI-SDK code. Okay. DI session, and oh, that's right. We have a function for this. Here it is. Where was it? Find lines. Find lines is what we need to call. And in order to find lines, we need to find compilin, and the compilin should match the source file. So let's see here. Just gonna steal that guy. This is what needs to, okay, hold on. I'm modifying the wrong thing. I do this so often, oh my god. This should have gone here. Okay. So find children, find session, find children takes a name. Good. The third parameter is the third parameter is a name? Wait, session. Oh, this is a symbol. This is the global symbol. So I need to find DIA symbol, find children. Okay, the second parameter is a name. So I can do source file dot wstring dot c underscore string. Let's see whether that matches up with the other uses of find children. Yeah, it's probably fine. There are only two. Okay, okay, okay. Enum compilins. Okay, so I need to write a loop here. Enum compilins, and this will be a actually, let's find that other, let's see, enum compilin, yeah. And actually, we did the same thing up there, didn't we? Find lines. Oh, right, yeah. Source file is enum source files. Wait. Was I not paying attention here? Find children. Find lines. Oh, I need a compilin and a source file. Wait, isn't that redundant? Oh, because of course, because a compilin can have multiple source files. I was confusing the concept of a compilin and a source file. I think actually what I need to do is get all compilins, and then for all compilins, search in them for a particular search file. Yeah, so I actually need to do something that more closely resembles what I've done up here. Here, let's just do this. Boink. Find file. I do not need a regular expression. .wstring. Enum source files. Okay. Expected one source file. There should be exactly one source file. I agree. Okay. So we grab that source file. And then we enumerate compilins. Compilins could be in the order of like, maybe even up to 1,000. Probably not that big of a deal to enum compilins. The question is like, can we reduce compilins that don't have our code in it by putting something here? And I don't think so. Well, hopefully it won't be slow. We'll see. We will see. If it is slow, then I'll have to do something like build my own map behind the scenes, and that might be gross. Haven't had to do anything like that yet. Yeah, thinking about that. That would be very hairy. Hopefully we don't have to do something like that. Okay, line number. Get line number. Great, then we just tack this onto our result vector that we're building, that we definitely have right here. Int 64t result. And we don't need the virtual address, do we? Do we need the virtual address? Do we need any other information line number has to give us? Line number. Line number. We already know the source file. I don't think we need to know the virtual address. No, not, and we don't even know that the virtual address at this point because the file might not even be loaded into the executable might not be loaded into memory at this point. The virtual address, you can only know it once you do that. You know the relative virtual address, but not the virtual address. So line number end. What? Of course. Of course. Interesting. Column number. Retrieves the column number whether expression or statement begins. Wait. DIA SDK can get me stuff about statements. That's good news. Man, there's a lot of stuff packed in this library. Okay, compiland. We already know. Yeah. So line number, the difference between line number start and line number end, we might be interested in it. So we'll do this. Line start, line end. Line start, line end. And don't need any of this stuff. So the question is what to do with this line start and line end stuff. Because I could like add every number between the two. Like I could just loop from start to end and add, you know, if start is 1 and end is 5, then I could add 1, 2, 3, 4, 5. But then what if the user sets a breakpoint on 5? Is it going to actually recognize that? Like breakpoint. Let's see, where do I actually set a breakpoint here? What is my... Can't find addresses for source location. Can't find addresses for source location. Oh. Can't find addresses for source location. Okay. Oops. Oh, it's we could get addresses for source location. Okay, so we'll eventually come back to this file. Get addresses for source location. Literally the same code that I just copy pasted. Okay, so I could just expand this and say... Yeah, that's what I'm going to do. Watch this. Line. Start. Line. End. See here I have if line is not equal to the one that we want, continue. But here I'm going to say if line, source location line, get addresses for source location. I guess from the documentation, virtual address, it gets virtual address, and then the number of bytes in a block? That's got to be like the virtual address of the line number, and then the number of bytes in that. Addresses. I think we only need the first address anyway, because we're setting a breakpoint on the first address. Yeah. So we'll say if line is not equal to, if line, I'm going to reverse this logic to make it a little easier for me to, man, math is hard. I clearly wasted my math degree. Okay. Line. If this line is the source location line that we want. So instead, this is going to say if the line we want is greater than or equal to line start, and the line we want is less than or equal to line end. Okay. Yeah, so in other words, if the line that we want is between line start and line end. Great. Cool. Now I support multiple statements that span multiple lines. Cool. So then we're just going to, for k equals line start, k is less than or equal to line end, k plus plus, result dot push back k, and just loop over d words, but then convert it here in 64 to, actually it's not even going to complain about that. Yeah, I think that means that DIASDK doesn't support more than 65,000 lines in a file. I'm fine with that. Okay. Result.pushback. So this is a valid, these are the valid lines in this file is basically what it's saying. For every line number in this file, in this compiland, yeah, that looks like what we want right there. Boom. We did it. We did it. Let's check in with our compiler and see what I messed up. It is compiling. I knew it. I knew it. Second is not a member of result iterator, blah, blah, blah. I have to do this probably. Arrow second. Is it dot second or arrow second? Who knows? Who knows? Will that fix it? That will fix it. Illegal use of this type as an expression. Invoke results. I don't have to cast it anymore. I can just assign it. Because I'm not constructing a unique pointer. Arrow second. I guessed wrong, and now all of these are going to be wrong. I guessed wrong every time. Literally. Every time. Symbol does not have overloaded. Oh my god. Did I guess right? Maybe I just didn't read the... Sometimes it's dot and sometimes it's arrow. Oh, it's that. This should be a dot. And this should be a dot. But up here it's an arrow? this iterator is an arrow, but this one is a dot. I'll never understand you, C++. Like, I'm sure there's a good reason for it underneath, but I wish they had found a better... What did I do here? Like, I wish they had not done that. Like, I wish they had done some more engineering to make it so that that reason didn't have to be... wait. Term does not evaluate to a function. So I'm... There's something that's not hashable. I'm using a... Oh no. Can it not hash file system paths? Really? See reference to variable. No throw hash being compiled while compiling. Yeah, it doesn't know how to hash file system paths. They're just strings. Just hash the underlying string. Okay, I'll just hash the underlying string. Dear C++, please make it so that I can hash file system paths. Much appreciated. Yours truly, me. Okay. This is now a string. I have to say, oops, dot string. Okay. Okay. Oh, that's not good. Source path. There, done. Result redefinition. Oh, yeah, that's fine. Okay. So far, so good. Okay. Looks like maybe we might get away with having written all this code. And if it were not for that undefined symbol, if I press F, this one right here, if I press F5, if I like create a stub, and then I press F5, I think we have a working subset of features that, namely that it will show, unless there are bugs, which are probably bugs that I would have to work out, but it will show which lines are debuggable at this point. I think I've done all of the code that I need to do for that. So the two things left to do are reload it. Actually, there's one thing left to do. Yeah. Which is reload it if I... No. So there are two things, yeah. One is to redraw the widget if once the message comes in. In the case of the file searcher, which is set waiting for source files, and it needs to redraw it, like add the new files. And in the case of the code area, it just needs to invalidate, so it will draw again. So it will draw these boxes again. So yeah, that's one thing that I need to do. The other thing is I need to, when the DIA SDK is cycled, because we load a new binary, we need to invalidate everything in this cache. That's what we have to do. The former is pretty straightforward. I know how I'm going to do that. But the latter is the only thing that is still fuzzy for me that I have to think about. Let's go look at that code. That always helps firm things up. Symbol query. Oh, wait a minute. I never reload the symbol query. Huh. Symbol query is the container for all the DIA SDK stuff. And it looks like while I may... Yeah, I just reworked how this code works a little while ago. And it looks like so I reworked it so that it doesn't have to restart the debug thread in order to restart the debugging. So it will just hang out here for while the debugger is stopped. Shut it down if it gets the shutdown message, but then launch a process. This is all like process launching code. Create process W here at the end. And then what I've just realized is right here, I need to refresh the symbol query. No, actually right where? Where do I need to do it? Here maybe? Right now I never refresh symbol query, so it's like the third bug that I've realized I've had on stream, so this has been very productive. If you have symbol query, so if you have the DI-SDK, the debug library loaded, and right now I'm just loading it from memory. Here's how I do it. Here's the executable. And then I call initialize. I think I just have to recall initialize, yeah. Or wait, maybe not just recall initialize because we don't want to do this stuff again. But where's the shutdown? Where does it kill it? Yeah, that stuff. But I can take all of this and move it into a different function. And this just reads the file into a buffer. I do it that way because I want to be able to query it without locking the PDB file so that the PDB file can be re-accessed. So I read it into this buffer and then I load it from a stream, open session, do all the stuff that I need to do. So I can just like take the yeah, I know what I have to do. Okay, so first I have to support recompiling. If it has been recompiled, I need to like dump what it has and create it again. I'm gonna take everything and initialize, move it up here to be closer with the other code that is actually related to it. So it's now next to the destructor. Okay, just moved the code from one place to another, no big deal there. Initialize, so now we're going to call, we're gonna move this stuff over here, assert not initialized. Let's do this. Okay. Initialize and also destroy. Okay. And now we can say initialize void symbol query destroy. And we can take this stuff you can stay though. And move it to destroy. And you stay behind. Okay, so it will only destroy if let's do it. Let's write the code this way. If it doesn't exist, or if it's not initialized, return. There. So it will only actually do the destroy if there is something to destroy. So we'll just go ahead and call destroy everywhere we need to call it. Destroy. Okay. Cool. Now I can come back to the debug thread. M symbol query reinitialize. Reload PDB. Cool, except that, does that mean that I'm going to be creating this stream over and over? What is this stream? Private M memory stream. Oh, but I do destroy the stream. No, I do not. Create stream on global. I should probably destroy this stream as well. All right, create stream. How do I destroy stream? Delete on release. Oh, okay. So that does it. Delete on release. Oh, I just need to call like stream arrow release. Destroy. If. No, I need to do this. Where is the, what is this thing? iStreamCom pointer. M private memory stream release. Yeah, I think that's what I need to do. We'll see. I do have tests. Tests will tell me whether I'm doing anything wrong here. Okay, so that destroys the memory stream from which I load all of the data in the PDB. Cool. Cool. Okay. That will reload the PDB file at the appropriate time. Now, if I do that, then I need to invalidate everything in that cache. How do I do that? I'm just going to do the shortcut. Symbol data cache bus. Okay, watch the shortcut. Here we go. The shortcut. Void. Invalidate. Okay, now. So we're just going to call it directly. Invalidate. Invalidate. And this, we can make this bus be a, no, wait, what am I doing? Singleton event bus. We can give it a mutex. And by doing so, for free, we'll make it a a bus that works across threads. That means that you will have to call. Should I make another bus for that? There's like a performance issue. If I type stud mutex here, then it will have to lock a mutex every time I call one of these things. I think that will not actually be very expensive. Like, you don't want to lock a mutex when you call this one, only this one. You know, if I'm going to do that, then why should I pump all these messages through the thread queues? Why don't I just fulfill my own promises? Why don't I just like say data is ready? Data, like this can be invalidate and data ready. And this get all source files could be backed directly by symbol query. Why don't I do that? Wouldn't that be so much easier? Wouldn't that just be like easy? Why shouldn't I do that? It means that it means that all the symbol data doesn't go over the same bus that that all the debug data goes over. I think I'm totally fine with that. I think I'm like 100% fine with that. Oof. It doesn't mean that like ooh, I have to think about this. Multi-threaded stuff is hard. Right now, I channel all of my multi-threaded messaging between almost all, not quite all. I do have some other exceptions elsewhere. I channel the majority of my traffic through a queue. And so like if I have a debug event, an event coming straight from the debugger, but I also have like information like this, they all have to get in the same line to go from thread to thread. So everything is sequential, and it makes it really easy to handle the multi-threading situation without a lot of additional complexity. And it means that the UI is going to be still responsive, even if the debugger is handling some really heavy-duty stuff in the back end. But like I already have another situation where well, logging, of course, is multi-threaded. Don't I have? Yeah, the type collection bus. The type collection bus. So the types don't go over that same queue that everything else does. So that the DISTK calls that I make can add types globally to every thread without them having to go through that queue. Man, that would just be a mess, right? So it calls these functions directly and tells the type collection, hey, this type exists now, that type exists now. So those types arrive in the UI thread's hands before anything gets through the event queue. The message queue. And I could do something like that here. Here's going to be where the kicker happens, okay? I request get all source files. And then the debug thread is going to immediately block on it. Whatever, no, that's not true. That's not necessarily true, actually. Yeah, so what can happen is like, I call this, the debug thread says, I don't have it right now, returns immediately. And then every so often, I have to call in here, mquery, mSymbolQuery dot, hey, check to do any processing that you have that came directly from the UI thread, right? Like right now, I only do it when I get a message. You know, I say mSymbolQuery, do some stuff. But what I actually have to do now is up here in this loop, where is it? Here. where I check for messages every, how often? 100 milliseconds. Okay. Then I have to say, hey, symbol query part of this thread, now you check to make sure you have any, like to make sure that you do any outstanding work that you have to do. Go ahead and do that work. And then when it's done, I think this is the way to do it, honestly. Because then we can get this stuff. Yeah, this is it. This is the way to do it. Because right now it just does all the processing at once. Whoops. At once. Right here. And that could be like at an inopportune time. Well, I am checking for messages. It's going to block as it does it, though. I think this is what I want to do. So I wouldn't do it for this one because this one gets source location of main procedure. Wants to come back over that bus because it's like a message bit. So maybe this is like, this is my razor. Okay. If it's an event that has to happen, then it needs to go over that message queue with everything else. If I don't need to fire off a specific event, I just want to get data sometimes, then I can do it over this bus. Maybe that's how I decide what data to send through the message queue and what data to send over this bus. I've been programming for so long, and multi-threaded stuff is still like, I feel like I'm a little baby. Like not how to do it, like I understand how threads work and how to send things across and stuff, but like what's the best way? I don't know that I'll ever really know that. I don't know that anyone can ever really know like what's the best way to do. I'm sure that computer science professionals spend a large part of their lives trying to figure out what the best way is to do this. And I am not a domain expert nearly to the degree that some people who work for like Microsoft and stuff are. I'm sure that a lot of people will have better ideas than I do. Okay. So if it is an event where it needs to do some concrete thing other than just like redisplay data, then it goes over the message queue. So get source location of main procedure. It wants to show that source location when it gets it. So that will go over the message queue. Get all source files is just, it wants to know all source files. Get debuggable source lines is like, just wants to display those source lines. It's going to display them when the data is ready, but it doesn't have to take any action. It just wants to cache that data and use it for later. Yeah, I think I should do this. But then my problem is, if I rework it to function like this, other people who come and touch this file may not realize that that's the intention of the design. So I'll just have to write some words here. This class is for storing, for persisting. I like persisting data that to be accessed at any later time. If you need to fire an event when the data is ready, instead put a request on the message queue, like get source location of main procedure. Now we delete a bunch of code. My favorite thing to do. Code deletion time. Here we go. Get source location of main procedure we keep. Get source location of main procedure we keep. Excuse me. Messages. Get source location of main procedure we keep. Debug engine. Get source location of main procedure we keep. We delete the other two. Yeah, there's no reason to enforce sequentialism. Like a queue is basically for enforcing sequentialism. Right? That's what this queue does. Add message to the queue. It enforces that first thing to go on the queue is the first thing that's going to come off the queue. That's not really necessary here. That's necessary in communicating between the debugger and the, but it's not necessary for just getting data that's not really going to change. For just querying data. Hey, give me data back. There's no reason that can't come back in any order. All right, I'm slowly convincing myself that this is the right way to do it. Okay. Debug engine, debug thread, debug engine, symbol query. So symbol query. What's the one other place that I have to update? Symbol data cache. You know what I think happens? I think this entire thing gets deleted and gets added to symbol query. Yeah, here's what happens. Boop. This comes over here. Final. Okay. These. Data ready goes away. Invalidate. Wait. These go away. Okay. Oops. Override. Cool. Cool. And now all this stuff, not the futures, but the data, gets to live down here now. And this guy. Okay. I think I get to delete pretty much everything in this file. I won't do it yet so I can copy things over to symbol query, but most of that stuff gets deleted. There's the listener. These are some function implementations. We won't need promise fulfilled anymore. Get all source files, get source location of main procedure. So get source location and main procedures first, just reorganizing code here. Not terribly interesting. Get all source files, returns a bool. Here's the result. Can delete that. Okay, but then we have this additional oh, and I should say result.clear. Okay. If we have the cache, then we return the cache value. If we don't need this. Otherwise, oh, we have to, it has to be initialized. Otherwise we have to say, here we have to say, we can't do it right now like we're doing it, okay? We have to say, I'll do it later. So we have to like set some kind of flag. Actually, get all source file. We should just cache that as soon as we initialize. Right? Right? Like, why wait? Just grab all the source files, stick them in a list right after we initialize. Why wouldn't we do that? So before, and I guess the answer is like, it delays the actual execution of the debugger. Let's do this so that we can pick a good time to do it. Compute all source files. You want this thing to just automatically start computing and sending back data. Return false. As soon as the program starts, like, is loaded. Like, as soon as it's loaded, pretty much. Void symbol, query, compute all source files. Okay. Boom. So we just have to take this and put it in the proper place. Run. Okay. So we load the executable. We create process. I think like right, it depends on how long it takes to create all the source files, to compute all the source files. Maybe it's like the sort of thing where you can do it a little bit at a time. You know what? I'm just not going to worry about this. I can profile this later. I'm just going to put it in initialize. Compute all source files. Stick that right at the bottom of initialize. We can do that more later. Like what I can do is right now the debugger pauses every 100 milliseconds. And I can do like loop for 10 milliseconds at a time through this thing. Okay. 10 milliseconds at a time. After I've processed it for 10 milliseconds, bail. Wait until the next time. Right? Come back and do a little bit more. That's probably out of scope of what I'm doing right now. If I have performance problems, I can definitely put in a system like that. It's like a chunking job system. It just adds this 10 milliseconds at a time so that it's always happening in the background. The user never really notices. And then when the data is available, it's available. It's done. So get debuggable source lines. Get debuggable source lines. You know what I'll actually do? For a first pass here, I'm gonna do not even what I just did where I pre-computed them. I'm just gonna return them. Okay. Debuggable lines, not futures. Debuggable lines, debuggable source lines. String equals the result that I just computed. Result. Oops. Result. Yep, I'll just compute it. I'll just block the debugging thread. Result. This, of course, will result in oh my god, I'm completely wrong. I'm completely wrong. I can't do this here. Yeah, I can't do this. See, this is exactly the problem. I have to do this. This function runs in the UI thread. I absolutely positively cannot actually do any DISTK calls in either of these. Where's the other one? Get debuggable source lines. Can't do it. Can't do it. So I have to debuggable source lines. Vector of string. Actually, file system path. Compute debuggable source lines queue. Okay. So what I actually have to do is add it to this queue. Dot push back source path. Whoops. Return false, and then pump the queue at a later point. Symbol query. Compute debuggable source lines. Then I say for stud file system path. That will be const source path. Wait. Yeah, source path. Compute debuggable lines queue. Then dunk all this into here. Clear the queue when I'm done. And do the invalidate. Do the invalidate step right there. Yeah, and I'll need to do the same thing for get all source files. So here's what I'm going to do. In the debug thread, we do this 100 millisecond wait, and then we check for messages. Let's see. Forward pipes UI. And then we check for messages. So inside check for messages, which we know is going to be called like a bunch, I'm going to do m symbol query dot compute lines. Is it ever, hold on. No, you know what I'm actually going to do? Because this might not be called, this might be called in times where I don't want this to happen. So here. This is while it's waiting to start, so we can definitely do some processing here. Ugh. Compute, I should just call this something more generic. Compute process. There. What a terrible name, process. An opportunity for the symbol queue to process things. Okay. Symbol query process. And we're also going to put it right here. Symbol query process. Do I put it before or after check for messages? I don't know. Yeah, that's probably fine. If, oh yeah. We don't care about that. And shut down, then break. Okay. Okay. So process, good. Whoops. Compute debuggable source lines. Okay, and then we'll put this there, and we'll also put this here. So this is the most naive version of it, where it just computes everything all the time. Compute debugger, so that's fine. And then this one, all source files. I guess I have to say, no, we don't want to do this all the time. We only want to do this if it has been requested. And if we initialize, then we have to reset it. Okay, so this is what we do. All source files. So at the end of initialize, we have to clear it all out. Let's do that. How do you clear an optional? Oh, you just set it to null, I'll bet. Equals null pointer. It's sometimes like a pointer and optional, and sometimes not. Okay. So good. And then also we're going to compute this guy. Debuggable source lines empty. Yeah, so we're just getting rid of the whole queue there. Okay. Getting rid of everything in the queue when we initialize, which is exactly what getting rid of all of our stashed data when we initialize. And then when we process, it will compute debuggable source file. We should also empty this, huh? Okay. When we process, it will compute debuggable source lines, which, there it goes. group this with all of the other similar code. Get source locations for address. Yeah, why is this down here? Compute debuggable source lines. And that, so get compute all source files. And then we only need to do this if, so if it's not empty, then return. So if we already computed source files, we don't have to compute source files again. Cool. These functions, I should call them methods because they're methods. These methods run in the UI thread. This method runs in the UI thread. Okay. Okay, we did it. We did it. So, when we initialize, we clear all the queued data. When we get a request, and when we get a request for something, let's look at this one. If it's present in the cache, we just return it. If it's not, then we add it to this queue of things that we want to process, to compute. It computes all of these things. It adds them in. It needs to call this invalidate function, which I'm not sure what that's going to be yet. Yeah, no idea what that's going to be yet. It needs to, yeah, there needs to be like another, I can delete this now, I think. This is gone. I think I just need another broadcast bus that does the opposite. Right? Symbol data cache bus events, and then symbol data cache updates. Symbol data updates events is what I need, right? So this will be like cache updated. Simple. And this is also, wait, no, that's not good. Yeah, my broadcast bus does not support multi-threading, as it shouldn't. Where's the, yeah. It does not support multi-threading, so this way is not going to work. I can't just have another broadcast bus that returns all the data, that returns all, that does all the invalidation. That's not going to work. So what it should do is put a message back on the debug message. There's like an invalidate, and isn't there? No, there's like a, there's a message that's just like, hey, promise fulfilled. Oh yeah, that's exactly what promise fulfilled does. Actually, so I just need to send a promise fulfilled message here. And then I can listen to promise fulfilled. This guy doesn't need to do anything because they'll just invalidate and he'll draw again. The other one, debugger screen. I no longer actually need this. Yeah. But here, Set waiting for source files. I need to, okay, so inside the file searcher, I need to listen for the promise fulfilled bus, check to see whether there is data on this bus. You know what? Why am I even doing this? Why bother passing this data in here? It's kind of silly, isn't it? File searcher will just not accept a list of files. Doesn't need to. Okay. And it will do this logic inside of itself. Okay. See? I can do the logic on my own. Okay. So if the data is available, it will, I wish that Sublime, when it's doing its autocomplete, would borrow things from the other side of the screen. So this can be private now. Okay, so then all it's going to do is, if there's data available, it will set the list. If there's not, it will set waiting for source files. It will be listening. I'm going to leave this unimplemented for now until I fix all the compiler errors I just wrote. But it will be listening right here, waiting for source files. It will be listening to the promise fulfilled bus and then call this when it sees that there's stuff available on here. Easy. Easy peasy. Then all I need to do is symbol query needs to call this promise fulfilled when it's done calculating stuff. And we'll do that like this. Okay. Process will just return to the debug thread whether it should send the promise fulfilled message. Cool. And there's one more of those. Cool. That should work. Okay, I actually need to do this. So I have to return true if something was computed. Bool. Something computed equals false. Something computed equals true. Return something computed. And same thing with these. Return false. Return true. Okay, cool. Cool. I think that might be it. Oh my God. I think I just did all that coding to change everything around so that the symbol query object directly handles these methods. Okay. Let's see what compiler errors we have. I'm sure I missed something. Like, that was a lot of state to keep in my head all at the same time. get all source file. Like there are syntax errors, but I'm sure there are going to also be semantic errors. We don't need this message anymore. Like for example, promise fulfilled. Just calls onto this bus, huh? Here's one place that listens. And where's the other place that listens? Symbol data cache. Promise fulfilled. Oh yeah, that's... oh yeah, this entire file like goes away now. I don't need it anymore. Right. So I actually think I do need symbol data cache is not a class or namespace. What? Oh, I just need to local include symbol data cache.h. I still need to invalidate at some point. I'm not actually doing it. Oh, these aren't override. Attempting to reference a deleted function. Symbol query. Because symbol query has a user-defined move assignment op. I put something. One of these things that I added doesn't have a copy constructor. Darn it. Is it the stud optional? What is it? Can I just do this? I don't quite get what it's complaining about. I literally just defined one. It was implicitly deleted because a base class invokes a deleted or inaccessible function. Oh, that's what I added. Function was implicitly deleted because of the, yeah, the listener. The listener is the thing that's not copyable. Oh man. Okay, well, you know what? I don't even need this. I can just, I think both of the initializes happen inside this function. Yeah, so I'll just, I think I can do this. And I don't actually use this here. So I can put it here instead. I can put this here. And then we avoid the whole shebang. This goes here. This goes here. Done. If you're gonna insist. Oh, right. Okay. Stop with the red. Stop getting angry at me. Yeah, I guessed wrong. Okay. Stud optional. Let's look it up again. Dot reset. Should probably have this down here too, huh? All source files is an optional. Oh. Compute all source files. If we have source files, return. Oh, wait. All source files is a stud optional. Equals stud vector of stud file system path constructor. And then this is an arrow. If I have one, don't compute anything. Great. Cool. This can be source path. I don't have to call this result iterator anymore. I can just call it iterator because there's only one map now. Oh, so I have to do... It's like the third time I've changed that line back and forth. Okay. It's looking good. Oh, whoa, whoa, whoa. Fair, fair. Oh, right. Where was that? Okay. I have a feeling that this is all going to crash and burn. I've made way too many changes. I've done way too much crazy stuff in one change list. I'm just paranoid that I goofed somewhere in my thinking, right? In whether I can allow these threads to communicate in that way. In some like major state problem, that means that I'm gonna have to. Yeah, it's pretty. I don't know. Oh, I don't have this object anymore. I'm gonna get to some point in like debugging it and trying to figure out what you know, whether it's working. I'm gonna realize some huge error that I did, and it's just gonna all fall apart. But this is what you're paying money for, folks. Watch me struggle with this crap on stream. Okay, set waiting for source files. We're back here. So the one major thing that I still haven't dealt with is actually invalidating the screen. The debug thread will send a promise fulfilled message, but I have to listen to it somewhere. So I think the code text error now has to listen to its own promise fulfilled message. So let's do that. Debug updates listener. It needs to be 1. Time to break this into separate lines. Okay, debug updates bus. It needs to implement things. I think I can do this. I think I can put it in the private section. I think it's fine. Override. Go down to the end. Code text area. Promise fulfilled. If we're just going to do this the easy way. Invalidate. So this means that I'm not listening for like the exact mess. Like this could be a different promise, but this thing still happens to return true, and it will still invalidate. But I think invalidating is kind of cheap. Actually, all it does is repaint, and repainting should happen within a few milliseconds anyway. If not, I have other problems, so I should be able to just call invalidate here. But I at least like filter it somewhat, you know. So that will solve that part of the problem. Oh, and I also have to actually listen on this bus. Debug updates, listener. Okay. Cool. Cool. Symbol data cache bus. Oh, right. Cool. Fair. So that takes care of that one, and then there is the finder. The file searcher. File searcher is the other half of this. We should have, we're back to unresolved external symbol. This one I can stand to be a little bit more exclusive about what I wait on. So we're finally going to implement this. And we implement it by waiting for source files equals false. And now it equals true. And we're going to do the same thing as before. I'm so organized with my headers. No judgments. Okay, debug updates bus. And we're going to listen on it. Okay. And we're going to promise fulfilled. And if we are waiting for a particular message, we're waiting for source files. I don't even have to, what am I doing? I don't even need this function anymore. Okay, if we're waiting for source files and they are, I have too many files open. Too many files open. Hello? And they are wait, get all source files is what I want. All source files. Okay. Then whew. I think I'm done writing all the code that I need to write. Barring whatever I didn't realize I just got wrong in the last 2 or 3 hours. Promise fulfilled is not declared. Oh, right. I did miss something. Promise fulfilled. Promise fulfilled. Always dangerous to write 3 whole hours of code and never run any of it, because I'm sure there will be some things wrong. Or maybe it'll just all work the first time. Maybe. How did that compile? Wasn't I running? I don't understand how that compiled. I was running Lux in the background the whole time. It shouldn't have compiled. Weird. Weird. Okay, well. Maybe it didn't. Oh, that's why I was running the release version of Lux. Okay, stop. Cancel. I regret everything. Okay. Okay. The moment of truth. Yeah, there it is. Already. Promise fulfilled. Wow, what on earth? How is that? What is the crash here? Bus handlers, there are 5. They look valid. Yeah, they're all valid. Exception thrown. Access reading location. But you're not on a... Debug updates engine bus. Debug updates bus events. V call? I don't understand. I'm so confused, alright? Let's back it up. Let's back it up. Oh, I think I know what happened. Invoke event is 0? That doesn't sound right. Okay. That's fine. Oh, so it just didn't happen on the first one. Oh no. It jumped to, you can see it jumped. Oh, so this is showing something different than it did before. It's saying it's at like RIP is 0 now. Like it somehow jumped to the 0 memory address. I knew it. I knew it, you guys. I knew it couldn't be beautiful. Never works on the first try. Nothing this complex ever works on the first try. Okay. This is so weird because this is not broadcast. It just should just be like jumping through, right? Set message callback. Check for messages. What is the problem here? Maybe it's because I made those things private. Wouldn't that be silly? Maybe it doesn't like it that I made them private. This is a stab in the dark here. But we're going to try it. You never know. Can you call into private methods like that? Is that a thing? Can you do that? No, that didn't matter at all. Access violation, executing location 0. It for some reason jumped to the null pointer. But why would it? I don't understand. Go to disassembly. What's going on? It jumped to... No, this isn't the instruction that jumped. This is the return address. After it jumps, it will come here. Is this... Yeah, it was running this code. It would have to have been. And then Visual Studio inserted all this crap. 9BB2, 9BAE, a call instruction. So, yeah, that's like 6 bytes or something. Sounds about right for a call instruction. So, okay. So it tried to call invoke event. This bus handler must have been invalid. Bus handler was null. Null bus handler. Null bus handler, that's my bet. Problem is, yeah, there are a lot of bus handler. You know what I can do? I'll have to recompile everything, but I can just put a little assert in here that says assert bus handler trying to call into a null bus handler. I will also put these back to being private. Now I have to recompile everything. Why? How could there be a null bus handler though? The whole point of the bus listener is that it destroys itself out of that list. If the listener gets destroyed, it removes itself from this list using some C++ magic. So this should never be null. That's why I didn't have an assert there. Well, I made a spelling error. Gonna have to recompile it all again. I don't think I need to wait for the tester. Okay, it's done anyway. And load and bonk. The assert did not hit. Okay. Debug engine, check for messages. Gonna just stick a breakpoint right there. So 1, 2. Okay, so the crash is on the second one. One, 2. So we're now looking at the crash. Bus handlers. They all look fine. Invoke event. One of these is null. Which one? Okay, so processes panel, file searcher, debugger screen, debug application. Processes panel, file searcher, debugger screen, debug application. That one. Debug application? That's in main. Oops. Hello, main. Debug application. This should like never be destroyed. This should exist always. Okay. Two, 3. This bus handler is invalid. What the hell? Process messages. How is this invalid? Wait, what is this? What is DDD again? One of the things I want to do with Lux is that if it ever sees a memory pattern like this, it knows it's in Visual Studio and it knows Visual Studio's memory patterns. It will tell you instead of you having to go look it up. DDD I think is free. Yeah, it's freed memory. Debugging heap to mark freed. Heap memory. Okay, something was freed. Something was freed. That's all fine. These all look fine. Yeah, okay, well, of course. Wait, I'm so confused. Bus handler is freed, but this has to be an element of this. Oh. I think I know. Maybe it was deleted as part of a previous broadcast. Uh-oh. Uh-oh. So that's the first one. So 1, 2, 3. Bus handlers is 4. Yeah, and then it's going to invoke. And we are going to show source location. Which does something that moves some memory around somehow. No, this wouldn't do it. Could something in show line do it? What's my memory look like here? Man, this is a tricky one. Oh no. That all looks fine. Get panel. Invalidate. Calls GUI invalidate. Which calls into, oh no, here we go. Debugger window invalidate. That doesn't change anything though. Hold on, now there are 5 bus handlers. There were only 4 when we started, so something was added. Something was added to that bus handler list. Let's try one more time. Okay. This is the problem. Something was added to the list in the middle of the iteration. Yeah, see, it starts as 4. So when the first one is called, it's fine. When the second one is called, it's fine. When the third one is called, now it's 5. So the third one adds something to that list. So first one, second one, third one. Okay, somewhere in here, something gets added to that list. It has to be. And where do things get added to that list? Here. Whoops. Go back. I pressed F10 instead of F9. Whoops. Here things get added to the list. Okay. Show yourself. Code text area gets created? Of course it does. Show source, okay. Promise fulfilled. Show source location. Because a tab is added. And so a code tab, oh my god. Wow, I have never run into this case before. So what's happening is something is getting added to the bus in the middle of walking the bus handler. Meaning that this memory that the vector is using gets corrupted. So I need like a I need to protect against this in the future, and then I need to disallow adding anything to this bus. I need to disallow adding, so I need to do 2 things. I need to disallow adding anything to the bus while we're iterating the bus. Or I wonder whether it would fix it if I just like, if I iterated by integer instead of this range 4. Maybe I can just like say int k equals, that would probably work. Is it really, like, it's like not okay to add something to the bus while we're iterating the bus. That is not okay. Not okay. So I guess what I could do is, here's a possible solution. If I call this code while this code is active, then it doesn't actually, it does like a separate path. It doesn't add it here. Instead, it saves it somewhere else and then adds it there. Like after the end. That's gross. I don't want to do that either. But Debugger screen promise fulfilled wants to show the source location, and showing source location wants to create a tab. I don't see any way to get around that. And creating a tab wants to listen on this bus. It's a circular dependency. What do I do now? I'm so close. I just have to defeat you. Thank you, Blitz. Can I defer this work? Can I show source location at a different time? Oh my God, stop it. I don't know. No. Oh my God. Can I... Promise fulfilled. I can't really defer anything in this chain because then there's nothing to come back to it. Like there's no way to come back to it and say, okay, do it now. So even if I put an error in here, it's like, okay, I run into that error. How am I supposed to change things? I think the best plan, because bus handlers is still valid. Get handlers returns the same static memory location no matter what. So I think the best plan is just turn this into a integer loop instead of a range for. Because what's happening is this pushback happens, and then the underlying memory of the vector gets changed. The underlying memory of the vector gets changed. So if I go into raw view, so this is CB30. If I F10, the thing has been added. Going back into raw view, it is now, oh, it's still CB30, huh. Okay. And it was added to the back. So this should work fine. Well, I guess I just got lucky that time, though, right? Like, the underlying memory could change. Wait a minute. This should now say 5. Something was just added. It should now say 5. Maybe Visual Studio's lying to me? I don't know. Anyway, something definitely could change. So, yeah, it's entirely plausible. You add something onto this vector, a bus handler pointer. All the bus handler pointers are still valid, but the vector, the memory in the vector has been relocated. And so it comes back here and tries to, that means these iterators have been invalidated. So if I change this into an integer loop, then it will just re-access the vector and there are no iterators involved to be invalidated. Is that okay? Is that like a thing that I don't mind doing? Is it okay that a bus listener adds something to the bus in the middle of the bus call? That seems like not okay. But I can't think of any other way to do it other than like it gets added to a special separate list that then gets tacked on at the end of the bus. But that's like maybe not even the behavior that you want. It's fine. It's fine. This is exactly what I was talking about before when I was like, something semantic I'll have done that I wasn't accounting for will cause a big problem. This is exactly what I meant. I called it. You heard me say it earlier in this video stream. And then it happened. So this means that any object that adds something to the bus, so if I'm a bus listener, and I create an object that becomes a bus listener during this bus event, then it will get the event that I'm broadcasting right now. And so if that object is the same as me, and that's like this could be an infinite loop of creating objects that then listen to the bus and then get the event and then create an object and then listen to the bus and then get the event and then like, right, you keep pushing things to the end of that list and they keep listening. So that is the thing that I'm putting myself in danger of by allowing this. I think it's pretty rare and it's not necessarily going to happen. If I am academically creating the perfect broadcast event bus that I'm sure will never have any errors and I can deploy to the world, if I'm working at like Facebook or Google and I think tens or hundreds of thousands of engineers are going to use this, then maybe I do something about that. But like in my own use case, it's probably pretty rare that this is going to happen. If it does happen, then you get a pretty obvious Stack Overflow, right? Stack Overflows are easy to find. And then you can go do something like it's way easier to not do that than it is to solve my current problem. Yeah, I think it's fine. Okay. So I'm immediately noticing that I'm not getting the little ticky marks that I noticed that I was expecting before. So we're going to go to the code text area and we're going to put a breakpoint here. Boom. And we're going to put a breakpoint here at the bottom. Here. Boom. And we're going to run this back. Okay. We don't have that. And we never get the invalidate. We never get the promise. So, well, let's try it again. Oh, we just got the promise. Weird. It just came through. Like too late after I already hit the back button. So that tells me that this part worked fine. Get debuggable source lines. Okay. This part probably worked fine. Oh, this part didn't work fine. This part didn't work fine. Okay. I think I know what's wrong. Debug thread dot process is not being called. Yeah, that's so weird. Where is the debug thread? Like, this is the one that I would have expected it call. Oh, it's because it's blocking. Oh no, it calls the blocking one because it's not running. Oh, it calls the blocking one. This is also what I was talking about when I was saying that there were semantic things that I get wrong. If it's running, it calls a non-blocking one, so it can get back to a busy, like a busy waiting loop. If it's not running, it doesn't do that. It doesn't do that. And so this is the thing that I wanted it to call. So that means if it's not running, then I can't actually get... You know what I can do? So if it gets a message, and if it gets like a fake, I can like send myself my own fake message, basically. If this happens. Yeah, I think I'll just do that. So here are my options. Right here, I have to push this thing back, and then I have to wait for it to call compute debuggable source lines. I can send a fake message, or I can change it so it's not blocking. But you know what? Hold on. I'm not going to worry about this a second. If that's true, that means that if I press this button, then the problem has been solved. Whoops. If it means that if I run the program, it should work because it's spinning at that point. Symbol query needs to initialized equals false. Okay. Where does it create unprivate? It creates it here. That's fine. All right. That's fair. Very fair. Let's try this again. We'll run it. Here we go. 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 Solved that problem. Solve that problem. Actually, I haven't solved that problem yet. Solve that problem. Wait, what? Read access violation. M data source is null. What? It is? Where is M data source created? Oh, here we go. Yeah, I have to do this here. Exactly where to do it, I think. Here. No. I'll do it here. Okay. This is actually no longer true. Okay, here's co-initialize, here's co-uninitialize. Here's the create the dia data source, and here's the destroy the dia data source. So okay, I'm just checking to make sure that it is symmetric, and it does appear to be symmetric. So that was a minor issue. That was no big deal. That was just a little. You know, little thing. Here we go. Here we go. We're getting so close. If I'm actually running the application, those breakpoint locations should show up unless something else is wrong. Didn't it just initialize though? Symbol query is initialized. If it's not initialized, say it's uninitialized, return false. But it is initialized. Okay. Debug thread. Wait. Symbol query. Oh. Symbol query. Okay. Initialize. Breakpoint. Oh, wait. Am I? Oh, okay, I am. There it is. Okay. Actually, no, I should put breakpoint where I set it to true and a breakpoint where I set it to false. Okay, it's initialized. F11. It's not initialized. It's initialized. It's not initialized. Wait. It's initialized. It's true. It's true. Okay. Okay. I think I know what's going on here. This is the definition of a race condition. The problem, see, it's initialized. It's not initialized. Okay. It's initialized. And now we're going to hop on over to the other thread. What's the other thread doing? Getting a stack trace. Symbol yeah, here it is. Here it is. It's like, oh man. It happened to hit this. It happened to walk into get debuggable source lines at the exact moment between when this thing was marked as non-initialized and when it was reinitialized. Okay. Man, it's true because I technically, in order to do this, I need to synchronize. Ah, crap. If I'm gonna destroy and initialize, I need to synchronize on the same mutex that is contained in the singleton event bus. That's what needs to happen. Symbol query destroy and initialize. Mainly initialize. Like mainly this function needs to be protected by the same. Okay, so let's see. Do I have access to that? Can I get access to it? This could have been so easy. Could have been easy. Symbol query has a bus listener inside of it. A bus listener is a unique pointer to a bus listener container, which contains a private bus handler, which contains the mutex. Yeah, maybe maybe I can add a function to this singleton event bus that's like, hey, lock it. I know I'm not calling it right now, but if I'm the owner, I'm allowed to lock it. Bus listener. Like I won't return. I just like return a lock guard object. Okay, I'll have a little function right here. Bus listener container. Is that okay? Put a little function bus listener container that's like lock. It returns that lock object. Throw it right in here in the definition of initialize. Bob's your uncle. Multi-threading, man, it's hard. It's hard. Holy cow. We got a bus handler in there. Bus handler has the mutex. That thing's public, so that's all I should need there. Is it okay to expose your lock to some random other person who could abuse your lock? Well, these are private objects, so you're the only person who's gonna. Yeah, you always put this in private. It's in private here, so the only person who's gonna abuse it is you. So that's fine. Okay, here we go. Lock. This is great. This is great. Okay, lock mutex. Lock return stud lock guard mutex bus handler m mutex. I just know that this is like gonna give me some kind of copy error. Like, you can't copy a lock guard. I just know it. I have to recompile my project like 4 times in a row. Anyway, let's do this. Bus symbol data cache bus listener lock stud lock guard stud mutex lock equals. And I'll call it guard. Hello and welcome to recompiling your whole project. Fortunately, it doesn't take very long. I'm so close. I'm so close. All I have to do is put a lock guard. So that means that makes this whole function into a critical section. Yeah, look at me modifying all this stuff right here. This should have been a critical section. I should have realized that. But multi-threaded programming is hard. And then, whoops. Oh, great. Here we go. No. Tried to lock a singleton bus with no listener. Okay, we're back in recompile her project land. So at the time where that function was trying to access, at this moment, it would have gotten stopped right here. It would not have actually gone into debuggable source line until the end of that critical section. And then at the end of the critical section, I think this will work. Okay. We can do it. The stream is a little bit on the longer side, but I'm obviously not going to finish all this tonight, but I at least want to get to the end of get the little breakpoints showing in the breakpoint window. If I can do that, I will be happy. I will go to bed. I will finish the rest of this tomorrow. I will write some tests. Definitely need tests here. I don't think I've ever written any tests on a stream. I'm not going to start today. Because I try and keep these videos to like an hour and a half or 2 hours, but somehow it always runs much longer. So, performing full link. We're almost done, folks. So as this thing links, I go over there, I press F5. Maybe we see some breakpoints. Then maybe I go play a game of League of Legends. You know? Why am I always streaming programming? Why don't I stream League of Legends sometimes? Or Crucible. Could stream some Crucible. Okay. Load. F11. Whoa. Whoa, what happened? Is this fine? Is this a crash? I think this is a crash. No, this is not a crash. Keep going. Okay, it wasn't a crash. It's just a breakpoint. Oh, my theory was wrong. It was incorrect. So it looks like this never ran. Oh, I'm just missing one of these somewhere. And the program is going to tell me where. Because I am paused again. Really? Right here. If I'm I just need to... I just need to process messages just before I go into being paused. Like these have not... This has not been hit because I've never been running before. Okay. Check for message. I mean, maybe I should just put it next to every check for messages. Maybe I should just put it inside check for messages. Like right here. I check, like check for, the whole point of check for messages is give the other threads an opportunity to have a say. I hit a breakpoint. It's not a pausing breakpoint, then continue, but check for messages first. Yeah, I could put it there. I could put it here. Oops. I think it skipped one. No, it didn't. Yeah, I'm just going to put it inside check for messages. Why not? It's probably going to cause me problems later. Just put it right here. Between every message. Before every message. Before checking for any message, do processing, send promise fulfilled. Is that okay? Will that cause me problems later? When I'm checking for... Am I ever going to be like, I wish I weren't doing processing and sending things... I can't imagine that would ever be a problem. It's probably fine. Oops. Oop. Yeah, baby. Let's go. Yeah, let's go. Oh, you saw it. You all saw it. Oh, yeah. There they are. Look at my little sweeties. My little babies. They're so pretty. Yeah, only took me 3 hours. These are all of the valid breakpoint locations. Yeah. Yeah. And you know, I can even like I did that whole multi-line thing. I actually want to see how that works out. Let's go And actually, I didn't even have to reboot the debugger for that, did I? Because it should let's test another thing. That probably won't work, but we'll see. Okay. So we're going to run it. No, we're not going to run it. I'll investigate what that was later. Definitely still problems here. Got to work out, but okay. Stop. Okay, good. So now I'm going to come in here. I'm going to go into types.cpp, which is the test file I'm using. I'm going to make a multi-line statement. This one. Boop. Gonna compile that. And it shouldn't have any hold on the file. See, it already updated the code. Shouldn't have any hold on the file. So it can't open Lux for types for writing. Oh, damn. So at this point, I'm not running it, and it shouldn't have a hold on it. Okay, I'll need to do some work on that then. We'll just kill Lux. Run it. Load it. Oh, it didn't do the multi-line thing. Okay. Well, baby steps. Baby steps. I'm pretty happy right there, honestly. Yeah, they're all off by 1 now. Until I stop. And F11 again. No, I would need to. Here, let me do this. Press back. And then if I go back in. Yeah, okay. Well, I need to do a lot of cleaning up for sure. But we've gotten the full loop in there, and we're just at the cleanup phase. So I can take the rest of it off stream. I have demoed the thing that I wanted to demo. So I'm pretty happy with this. Intended design is you have all these breakpoint locations. It won't let me hover the mouse over one that's not a breakpoint location. I can click, make breakpoint, click again to get rid of the breakpoint. And then if I create a breakpoint somewhere that becomes, because I recompile the program, a location that no longer accepts a breakpoint, then I move the breakpoint to somewhere that's valid. So that's the entire design. I'm going to keep working on this until that is the thing that Lux does. Thank you for joining me today. I had a lot of fun doing this. It was really exciting. I got to pretty fundamentally rework part of how the messaging model between threads works. That was crazy. It was, I'm glad that you all came on this adventure with me, where you watched me bang my head against it, metaphorically, for a few minutes. But I had a great time, so it was worth it. And if you want to give this a shot, I just released a new version this morning, and has all the stuff you see here. Doesn't have these things because I literally just did them, but it has everything else. This is a new debugger. I'm completely rethinking how debuggers work, the interface, the features, the functionality. If you want to say and how it develops over time, then please go to luxdebugger.com, click join the alpha, and you can try it for yourself. And I look forward to seeing your feedback. And the link to do that is down in the description. We'll see you here same time next week, Tuesday evening, around 8 o'clock Pacific time. And that wraps it up. Thank you for everybody for coming. See you next time.